You go start with the questions.
Yeah.
Okay. Okay.
Okay. So the question is, write a query to return all tables present in HR and sys schema. So first query, which table will you query? You need to decide which table you need to query. Because I'm asking for table related information, right?
Right. So here are from the all tables.
Yes, all underscore tables. Okay, now execute this. Okay, now do I want all schemas or do I want only specific schemas?
You want specific schema.
Oh, okay.
You
So
want
can you filter out?
owner in
Okay. Okay, that's the right answer. But do I want all columns or do I want only a specific column from the? Because now right now I'm returning owner, table name, table space, cluster, all of that information. So do I want only specific column or do I want all columns in my data?
to return all tables present in HR and
Yeah, but do I want others in columns also? Table space. So I don't want star. I want only table underscore name. So these are all the tables present in HR and sys schema. Okay, these are all the tables present in HR and sys
HR.
schema. Okay, is this clear to everyone? Zia, is this clear? Okay, next question. So write a query to return table name, column name, data type, and length for only varchar fields. So which table will you query?
All tab columns.
Yes, that's right.
All underscore tab underscore columns.
Because I'm asking for column related information, right?
Right.
Okay, so select star from all underscore tab underscore column.
I'll just
Okay. Do I want data for all tables and all schemas? No, right?
no.
I only want it for a specific table and specific schema, right?
Yeah.
Okay.
You want from HR schema.
Owner should be HR and table should be
Table
employees.
is employees, right? Where
Okay. Do I want, so what else do you have to filter on? Do
you
I
have
want
to
all data types or only specific data type?
you want specific data type.
Which data type do I want?
Varchar.
Okay, which one are you displaying right now? You're displaying number, varchar, date, everything, right?
Right.
Okay. So you need to filter out even more. Okay, now execute this. Okay. So now do I want to say star?
No,
Or do I want only specific columns?
you want specific columns. So you
Okay.
want
Table underscore name.
table name, column name, data type, and you want the length as well.
Yes, I want the length as well.
So length for Barker.
No, there is nothing called as length. It's called data underscore length. Look at the
Right.
okay. So I want you to return data which has all the columns from HR schema, and then the table is employees, and then data type is varchar, right?
Right.
And then if I told you the length should be only 25, because right now you're returning length 20 and 10,
Then
you'll have another and statement.
and statement, which is basically greater than 25 or
Then you will say and data underscore length equals to 25, right?
right.
That's how you
Yes.
can filter out even more. Okay.
You want me to, or
No,
just
that's okay. No, that's not the part of the question. I was just asking.
saying it? Okay.
Okay. So next question. Is this clear to everyone? Fareen? Zia? Zia, I cannot hear you. Is this clear? Okay. The next one. Okay, now I'm asking you to write a query to return total number of primary key constraints in HR schema. Okay. So which table will you query?
We have a table called all constraints.
Very good. Yes. So you have if you want table related information, you have all tables. If you want column related information, you have all tab columns. If you want constraints related information, you need to query all underscore constraints. Okay, can you query select star from all underscore constraints? Constraints, you're missing an S. Yeah, no, missing an S after and COS before T. Yeah, so query this table. This table will have all the constraints in the database. Okay, now do you want it for all schemas or for a specific schema?
Specific schema.
Okay, so you will filter on owner, where owner equals owner's schema, connection, user, these are all the same. Okay, where owner equals to sys, where owner equals HR. Okay, now execute this. Okay, do you want all constraint types or only a specific constraint type?
Specific constraint type.
Okay, what's the constraint type you want?
Constraint type would be P, primary
Okay.
key.
Okay, so P means primary key, right? And constraint underscore type equals P.
Okay.
So these are all the primary keys in HR schema. Okay, now look at the question. Do I want to display all the constraints or the count of constraints?
Even the count.
Okay. So get rid of star and put count. The moment somebody asks for total number and count, you have to use count star. So how many primary keys are there in HR schema? 11 primary keys.
Yeah, based on my
You can open each table and check. So I know countries table has one, departments table has one, DEPT underscore 1 underscore 11 has one. Yeah, you can open each one of them and verify, but you don't have to. Yeah, this one only has foreign key constraint. It doesn't have a primary key. Department, so first one has, second one has, department table has for sure. Go to constraints. This one has one primary key.
Yes.
Each table can have only one primary key. So employees, countries has one, departments has one, department underscore 1 underscore 11 has one, employees has one. And primary key constraint means you cannot insert duplicates, you cannot insert null
Null
values.
values.
Okay. So is this answer clear to everyone? Zia, Fareen, Krishna, is this clear? We are just querying the metadata tables to find out the number. You may not use this all the time. Good to know.
Yeah, it's clear. Thanks.
Let's go to the next question. So I asked you to create a table, 1 underscore 2 underscore prac, emp ID, first name, last name. Okay. So I think, did you already create that table?
I did, yes.
Okay, can you just drop it? Let's do it from scratch. Just drop this table.
Okay.
Okay. So now I want you to write a query to add not null constraint to the first name. Double click on this table. We do not have any constraints on this table, right? Emp underscore 1 underscore 2 prac, and go to constraints. Oh, you created
We
one
have
primary constraint. Yeah.
we have a primary key already.
Okay. Now the next question is, go back. Write a query to add a not null constraint. So you're not going to drop the table and recreate it, right? You have to modify an existing table. You have to use alter statement.
On a first name, right?
Yeah.
Alter table. Modify. Modify first name.
Not now. So once you execute this, you cannot insert null values or empty values into that column. Okay. Go to the table and refresh. Now you will see first name is not null.
Not null.
Automatically it will create a constraint. Okay. Now go back to the question. Let's do write a query to increase the length of last name to 25. Okay, let's write a query to increase the length of last name to 25. Okay, first we will do that and then we will add a unique constraint.
Right.
So once again, if you want to make changes to the structure of the table, you will have to use
Alter
statement.
alter statement, right?
So alter table name. Once again, modify
on last name.
underscore name. Right now, the length of the column is 20. It will only take in 20 characters, but we want to increase it to 25. Yeah, varchar cal to 25. Okay, now execute this.
You want me to add total or later?
Hold on, no, go to your, yeah, don't execute this. Go to your table where you double click on the table. Yeah, go to columns tab. Okay, so right now the last name is 15 characters, right? The length is 15.
Yes.
Let's increase it to 25. Okay, go back and execute that. Okay, go to your table. Now you have to just refresh. It will increase to 25. Is that clear to everyone? This is how you can increase the length of the column. Okay, you should never drop it and create it again. If you drop it, you will lose your data in it. Okay, next. The second part of the third, yes, and then I said, and also add a unique constraint.
So in this case,
Add.
that
No, not like alter table name, add unique and then last name.
okay.
So when you add a unique constraint on a column, you cannot insert duplicates in it. Can I execute this? Hold on. Alter table.
I think you have to make parenthesis with the last name.
Last name, okay. Okay, that's right. So now we added a unique constraint on last name. That means we cannot insert duplicates in this column now. Go to constraints tab. So we added a third constraint called unique constraint, and we cannot add duplicates in this column now. Okay, now go back. Write a query to change the name of the first column to employee ID. Right now it's emp ID, right? I want to change it to employee underscore ID. Okay, so once again, if you want to change the structure of the table, you will have to use alter statement.
Right. Oh, wrong. Okay. So it would be change the first column. Okay, what was the first?
First, you have emp ID, emp underscore ID.
Emp underscore ID.
You will first mention the old column name and then the new column name.
Wait, that's.
I don't think you have to use the word to.
So you mentioned the column. Rename column and then.
Column, yes.
Yeah.
Yeah, I think you have to mention two,
Okay.
isn't it? Yeah. I forgot about the
Yeah, just
column.
one is enough.
Yeah, as I was going through,
Okay.
you
Now,
have to practice to remember.
Yeah.
then I want you to add a brand new column. Let's check if that column got renamed. Go to columns tab and refresh it. Columns. Oh, it got changed. Previously it was emp ID. Now we renamed it to employee underscore ID. Any modifications you want to make to the structure of the table, you will have to use alter statement. Anything you want to change inside the table, like you want to change uppercase name from Abdul to uppercase Abdul, or you want to change department ID from 10 to 20, you have to use update statement. Okay. Anything to the skeleton of the table or the structure of the table, you will use alter statement. Anything to change inside the table, data in the table, you have to use update statement. Okay. Don't get confused between these two. Okay. Now I'm asking you to add a fourth column to the table called bonus. Okay. So once again, you want to change the structure of the table, you will write an alter statement.
Alter statement. Okay, now you want to add a column.
Yes. So alter table name, add, and just the column, whatever you want, bonus, and then number. Okay, execute this. Okay, go to your structure of the table and show me. Just refresh. Okay, a new column got added. It's a number field.
Okay.
Can you go back? Hold on. Can you go back? Yeah, it's 25 character. Okay, no, that's good. That's good. Now, what's the second part of that question? The one you just did? I also want you to add a, what kind of constraint? I'm saying bonus cannot be greater than 2000. What kind of constraint do I have to add here?
Check.
Check constraint. Okay. So can you add a check constraint? So once again, you want to change the structure of the table, you will use alter statement.
Alter statement, yeah.
Alter table name, add, check. How do you do it? Alter table name, add, check, add, check, and then column name. No, column name should not be in brackets, right?
When you put, okay.
Add check bonus, and then add check bonus less. No, I think you're right. Okay, you're right.
Oh.
Just put bracket and then bonus less than 2000. No, I think bonus.
Cannot be great.
Yeah, so less than, right?
Yeah, less than or equal to, I think.
No. I did
No,
not.
he said cannot be greater than.
Oh yeah, you're right. It has to be less than or equals to. Equal to symbol as well. Okay, execute this. Invalid relational operator. It's saying don't you have to put that in the brackets?
Yeah, I think it's including the 2000.
Yeah, inside the bracket it has
Yeah, bonus start and then the parenthesis after the bonus you put it, it should be after the 2000. Yeah, exactly. Yeah.
I did it all together.
Okay.
That worked.
Okay. No, you can do it all together, but I just want to split it out. So
You split it. You're right, right. So it's a
the people can understand.
two different type of queries, right?
Yeah, you can do it in one, but I want to make it sure that everybody is understanding this. Okay. Now that is done. And then write a query to create a new column state. Okay. Now I am once again I'm asking. Hold on. Show me the structure of the table. Go to constraints. We added a new constraint, check constraint, right? Constraints and refresh.
Yeah.
Okay. So in this column, you cannot enter a value greater than 2000. It will give you an error message. Okay. Now, so once again, what is a constraint? Constraint is to enforce a policy. Okay. So what is the constraint? What is the policy we are enforcing on the bonus column? The value cannot be more than 2000. Okay. Constraints are used to make your data cleaner. Okay. If you created a column called not null, you will not be able to insert a null value. If you created a column with primary key constraint on it, that means you cannot insert duplicates or null values. This is very, very important. They ask constraints, one of these constraints in every interview. In fact, they asked Atik this question yesterday, right, Atik?
Yes, they asked me yesterday.
They asked you 2 questions on constraints, right?
Correct. Yes.
They asked him 2 questions on constraints.
Unique and what is the difference between unique and primary key?
Yeah. So what is the difference between unique and primary key? In unique, you can insert you can insert null values, but in primary key constraint, you cannot insert null values. What is the similarity? Both of them cannot take duplicates. What is the difference? One will take in null values, one will not take in null values. Okay.
So when you create a primary key, it's automatically created unique in there.
Yeah. Whenever you
Basically.
create a primary key, it will automatically create a unique as well as not null constraint automatically.
Right.
Okay. 2 things will happen. Okay. So that is the reason primary key is equals to unique plus not null constraint. Okay. So write a query to create a new column. We already did this. We know how to add a new column, right? Once again, alter table name.
No. Come on. My number lock. Add a new column state. Do you want to put it all together or you want to separate it?
No, separate it out. You have to mention the data type, right?
Right.
Just keep it varchar 2 and 2. I don't think that will work. You're not saying the word default.
Oh, you wanted to separate it.
Yeah, okay.
Right?
So get rid
I'll
of that.
just get rid of the.
Yeah, get rid of that then. Okay, so first we will simply add a column. This is how you add a column to a table. Okay, go to the structure of the table, columns, and refresh. No, you're still on constraints tab. Okay, now you see a brand new column got added called state. Okay, now let's create a default constraint.
So
Once again, alter table name.
Mm. Is that how it should be?
Alter table name, add default.
I think
Not like that, right?
modify. Yeah.
Yeah.
In
You're
this
not
case, modify.
Yeah, modify. No add. No.
So a few times, sometimes constraint you have to add modify some.
No. It always is. So you have to do alter table name, modify city, modify default, modify which column? State.
Yeah.
So after modify, type in state, and then get rid of all of that, equal to and all of that. Modify state and then default, and then CA in single quotes.
So in this case, this constraint default, why are we modifying, not adding like
So we are
others?
modifying the existing column to add that. So default constraint is different. The way
Okay,
you do it, it's different than, because all of them will have add, right?
add,
This
right.
one you have to use modify. Okay.
Okay.
Okay. Now go to the constraints tab. You will not see default constraint. Okay. All other constraints will show up here except default constraint. Just refresh the screen. Okay. Default constraint will never show up in the constraints tab. All other constraints will show up here.
It
Okay.
shows in a
It shows
column
in the
level.
columns tab. It will not show up in the constraints tab.
Oh, okay. That's why it's not the other type of constraint. All
Yeah.
other
It is still a constraint,
constraint. Yeah.
but it will not show up like a regular constraint in the constraints tab. In fact, it will show up in the columns tab, saying that the default value. So that means if you keep that column empty, it will enter CA by itself. If you're entering a value, it will take in. If not, if you keep it empty, it will take in CA. Okay, now
So this is a constraint, but it's not. I mean, if you modify it, basically it's not a constraint level. It goes onto a column level.
Okay,
Okay.
now go to the next part of the question. Is that it? No, I think we had to add some data in this, right?
No. That.
Okay, that is it. Okay.
Yeah, add data onto the next.
Okay, that's the next one.
Next
Okay,
line.
so let's just play around with this table. Okay, can you insert one Abdul? Can you insert some data into this table? Insert into this table.
Insert into
1 comma Abdul comma 10 comma, and what are the other columns? Salary, right? No, bonus. Just click on the structure of the table. First, last name, bonus, and state. Okay, 1 Abdul Kader. Go back
where
down.
is it?
Kader, and then you have 10,000. Just type in no, type in 1,000. 1,000. There is no department ID.
No, there is
Get rid
so
of
it's
10 and type in 1,000 here, and then type in CA or type in NY and type in NY. NY should be in single quotes. Okay, execute this. Okay, one row inserted, right? So do a commit, do select star on the table. Okay, now let's enter another value in this table. Okay, copy and paste that below, that insert statement. Don't execute it, okay? Get rid of 1 and type in A. Will this work?
No,
Why not?
because the data type for employee ID is number and this is a character.
Okay, so can you type in 1? Will this work?
No,
Why?
because we have a primary key constraint, so it will violate, cannot enter duplicate.
Okay, make it 1 and execute. And can someone tell me what is the error message? Make it 1. No, don't execute that. Make it 1. Sorry, make it A.
Okay.
Can someone tell me what is the error message you will receive? We did this before. Okay, execute this.
The violated.
No, it will not. It will say column not allowed. Okay, because you are trying to insert a alphabet into a number field.
Column
Okay.
not allowed, yeah.
Make it 1 now. Now what's the error message you will receive?
Primary key,
No, unique
not,
constraint violated.
yeah, the constant.
Because
Unique,
primary key is made up of unique values and not null, right?
right,
Okay.
so
So execute this. You'll get an error message saying unique constraint violated. That means you're trying to insert a duplicate. Okay. And it will tell you which column. No, okay. It says unique constraint violated. Okay. So you cannot insert duplicate sets. So get rid of 1 and put 2. Will this work?
yeah, it's a whole.
This will not work. Why?
It's new NY.
No, NY works. Who told you NY doesn't work? You have other constraints, right?
Other,
What are the
let's
other
see.
constraints on the table?
We put
Unique constraint on last
unique
name, right?
constraint on
So
last
you
name.
cannot
Yeah.
insert duplicate. So execute that. It will fail because you have a unique constraint on last name. So Khader cannot be inserted again into this table. So it says, yeah, now it will say unique constraint violated. Okay, so get rid of Khader and just put KHA. Okay, will this work?
Yeah.
Okay, now execute this. Okay, now do a commit. Okay, now insert 3. No. Okay, here you're just copying it.
Yeah.
Okay, now try to insert value 3 and get rid of KHA and then just type in SAM. Okay, get rid of 1000 and type in 11,000 there. Will this work?
No, how much we put in?
2000.
2000, okay.
So
Yeah.
you enforced a policy saying that you cannot insert values greater than 2000, right? So execute this. It will fail. It will not let you enter the data. It says check constraint violated.
Constraint
What is the
violated.
check constraint? Value should always be less than 2000, right?
Yes.
Okay, make the value as 2000 and execute it. No, value should be less than or equal. So it will take in 2000. Yeah, execute this.
It will, because we put equal to.
Yeah. Now commit it. Now do select star on this table. Okay, now I want you to enter value 4. Now I want to enter a value 4 and then enter any name, other name, some other name. Okay, and then yeah, get it, change that. Okay, and then I don't want to enter ny. I want to keep that as empty. Okay, yeah. No, you cannot execute it like this, right? Because you only have 4 columns, you have to specify which 4 columns the data is going into, right?
Right.
If it's all 5, table has 5 columns, you're giving it 5 columns, it will insert it. Table has 5 columns, you're giving it 4 columns, then you have to specify which particular column that data is going in. So you're giving data to employee underscore ID, first underscore name, last underscore name, last underscore name, and then bonus. Okay, bracket close and execute. You're not entering anything into state column.
State column, right? It will.
Okay. Now do select star on this table. Since you did not enter anything into the state column, it will automatically enter what?
CA.
CA.
CA there. Because the default value is CA. Clear to everyone? Okay.
Yes.
Next question, please. Okay, we almost spent 1 hour on the assignment. I don't want to spend so much time. Okay, let's proceed.
So you want to continue or?
Actually, let's not do this. We already did this yesterday, right?
Right.
We did the exact same thing. We created 2 tables with, okay, let's finish it off. Let's finish it off, okay?
Okay, so I already, okay, no,
Yeah, drop those tables. No, you cannot drop master table first. That's the whole concept, right? You have to drop employee table first. You cannot drop department table first. Remember?
Yeah.
While inserting data, data should be inserted into master table first and then child table. While deleting data, yeah, should delete data from the child table first and then the master table. Okay, now drop the other table.
Okay, so I don't have any of these tables now.
Okay, let's do it from scratch.
I'll put lowercase.
Even if you create a table as lowercase, internally it will convert it
Same.
to uppercase.
Right.
Even if you create a column as lowercase, internally it will convert it to uppercase. And you will see on the left side, you see all the tables as uppercase only. So I'm asking you to create 2 tables. Okay. Hold on. Wait. Let me read the entire question. Scroll down. Okay.
The initially was like create 2 tables.
Good. So create this table. So table got created. Okay. Then I asked you to create another table, employee table.
Okay. Tables got created.
Okay. Now, my question here is write an alter statement to add a foreign key relationship between department ID and both tables. Okay, that means, what does that mean? When I enter a record into employees table, it should go and check if that department is present in the department table. Okay, let me share screen for a moment. We discussed this yesterday, but I just quickly want to refresh whatever we discussed yesterday. So when I enter information here, when I enter 1 Abdul 10 here, in my department table, I have 10 and IT. So when I enter an employee for 1 Abdul 10, it should go and check in this table if that value exists only then. So if department table only has department ID 10, this record should be inserted. When you're trying to insert this record, it should fail with the error message, integrity constraint violated. Why? Because this department ID 20 doesn't exist. So you have to create a foreign key relationship, foreign key constraint between these two columns. Is that clear?
Right.
And then this column should always be primary key. This is the master table, right? This should always be primary key. Is that clear to everyone?
Right. So in this case, based on your question, Abdul, since we wanted to create a foreign key relationship, then since two tables got created, so I must create a primary key on the department.
Very good. Yeah, that's the thing. You first have to create a primary key. Without creating a primary key, you cannot create a foreign key relationship. So first you need to create a primary key on this column. Then you need to create a foreign key. Okay. Let me stop sharing.
Okay.
So how do you create a primary key relationship?
Okay. So for the department, so I'll just write, change the table structure of the table. So alter table.
Yeah, alter table.
Okay. And okay. Where to check it?
Constraints.
Okay. Also,
Okay, now add a foreign key relationship between these two columns in these two tables, right?
right.
Okay, so alter table again. Any change to the structure of the table is altered. Okay, alter table, table name. So you're creating a foreign key on the child table, which is
Child table.
employee table. Yeah, alter table name, and then we did this yesterday. Add
Okay. Add
foreign key, and then in brackets you have to type in which column, DEPT underscore ID. So we are saying add foreign key on DEPT underscore ID references refere.
Reference.
This DPT. What's the column name? I cannot see. And then what's the and then in brackets? Is it DPT ID or DPT underscore? Okay. And execute this. Okay. Now you created a foreign key relationship. Okay. Try to insert data into employees table because department table is empty. It doesn't have any departments. Okay. Try to insert data into employees table.
Insert into.
So what will happen? Will you able to insert this? Will you be able to insert this?
No,
Why?
because the parent table, which is department table, does not have 10.
Department ID 10.
Right.
Execute this. It will give you an error message, integrity constraint violated. Okay. So that means department table should have department ID 10. Only then you can insert it, right? Otherwise, you will start hiring people into department which doesn't even exist, which doesn't make sense, right? If you did not have a foreign key, it would have let you insert this.
So if I do the column name and no department, then I would be able to, right?
Yeah.
Okay.
But
Then we'll say null for the
yeah,
department.
but the problem is you have to hire a person into a department, right? You cannot
Right.
just hire a person and say,
I'll just pay you for
yeah,
nothing.
without working for any department, right? Okay.
True.
So now insert a record into the department table. Let's wrap it up. It's already an hour. So insert one record into the department table, 10, IT.
Okay. Why?
Values. You have to use the word values.
Oh, yes. Yes. Okay. So it's missing keyword. Okay.
Okay. Now you can insert. Now it will let you insert because it can find a corresponding value. Okay. Now try to delete data from okay, you already did a commit. Try to delete data from master table now. Try to delete data from department table. Will it let you delete?
Master, no, because you have to clear the delete the child table first.
You have to not delete the child table. You have to delete the
I mean
record in the
the
child
child record.
Yeah, you have to delete the child record first. Only then you can delete the master record. Okay, now try to delete record from department table. it will not let you delete because it will say you have children record first. It says children record, child record found. So you have to delete from the, so try to delete record from the child table, employee table first, and then only then you can delete it from the, so when you insert data, it should be master table first and then child table. When you delete data, it should be child table first and then master.
Reverse. Okay. Do you want to delete or keep it?
No, delete it.
Okay. Where-
Okay, now you will be able to delete.
yeah.
Okay, is that clear? So this is how you create a foreign key primary key relationship between two tables. Okay, so when you create a foreign key primary key relationship, you can only enter data into a child table if that record exists in master table. So this is very useful when you're hiring a person into a department, and if that department doesn't even exist, it gives a lot of problems, right? So you create a foreign key primary key relationship between the department table and employee table. Department table is always going to be master table, and then employees table is going to be child table. Okay, I work at a bank. Okay, I have two tables. One is an account table, one is a customer account table, one is a transactions table. So which one is going to be master table and which one is going to be child table?
Customer.
I have two tables. Customer account, I have accounts table, and then I have transactions table.
Your account table should be the master table.
Yeah, why? Because if I am doing a transaction,
Without an account, you can't do any
we need an
transaction.
account first for it, right? Similarly, when you're hiring a person, there should be a department first, right? This was asked in an interview to someone, I don't remember who. Okay, let's take a 10-minute break and then we will be back. We'll cover joins and we will cover group by. Okay, we'll cover two important topics. Let's take a 10 minutes break. I'm going to stop recording and then we will be back.
Abdul Bhai, quick question.
Yeah.
For the W3 schools, the website, is it only going to work on Windows, or it can work on MacBook too?
W3 schools website, what do you mean work? You can access it from anywhere, right?
So it would be good to work on the Mac, because I tried when I put it in my MacBook, it gave me like an error.
You're running everything on the website, so that should work anywhere.
Yeah.
Yeah, that's what got me confused. So I was like, let me confirm if it works or not on a MacBook, because it should
It
be able to
should.
work anywhere.
So you mean you're trying to practice SQL statements on W3 schools?
Yeah, on MacBook.
Okay, it should work. It shouldn't be a problem. We'll
I'll
take a look at it once we are back. Once we are back from the break, we'll take a look at it.
All right.
Okay, I'm going to stop recording, okay?
Give me 1 second. My screen is frozen.
Okay. Yeah, I cannot see your screen yet.
Do you see it now?
Yeah. Yeah, can you open your W3 schools?
Yeah, give me 1 second. It's right here. Right. I figured out the problem while we were on break.
What was that?
I figured out the problem while we were on break.
So is it working now?
Yeah, it's working on my MacBook. My internet wasn't connected.
Oh,
Yeah,
okay.
because I saw the Wi-Fi thing. It was just like blinking. So I'm like, why is that blinking? And then I tried connecting it. After that, it worked.
Okay. Okay, so let me share screen, okay? Because we are going to cover a new topic.
Give me 1 second.
Okay, can everybody see my screen?
Yes.
Yes.
Okay, I'm going to cover something very important. It's called joins. Okay, and so in my HR schema, I have employees table, I have department table, I have jobs table, I have locations, I have all of these tables, right? Now, why do I have so many tables? Can I not just have one big table which has employee information, department information, job information, location? Can I not just have one big table which has emp ID? This is all employee related information: first name, last name, and then department ID, and then department name, and then job ID, and then job name, then location ID, and then location name. Can I not just have one big table with, so I can get rid of all these 4 tables? I can just have one big table called employee information. And no, that's not how it works. Okay, it's good. It's a very it's very difficult to maintain a table which is made up of 5 or 6 subject areas. That's the reason in databases the tables, the schema is divided into different tables. So we have employees table, we have department tables, we have job tables, we have locations table. Okay, if you have one big table with more than one subject area, it's called as denormalized table. For example, if you have a table like this: emp ID, name, department ID. Okay, these 3 columns are employee information, right? And then you have another table called department name, department budget, something like that. Okay, then this is department related information, right? This is department related information. So if you have a table which has more than one subject area in it, this is called as denormalized table. Okay, this is called as normalized. Is that clear? This is called as normalized. That means it is broken down. So this one big table is broken down into, this is employees and then this is department. Is that clear to everyone?
Yeah.
Now, the problem here is in employees table, I will have only employee related information. Okay, in department table, I have only department related information. For example, emp ID, name, and then I have department ID. Okay, I have one Abdul 10, and then I have two Atik 20. Now I have another table called department table, department ID and department name. Okay, I have 10, IT, and then I have 20 sales. If I want to know which department Abdul works on, so I will have to first query this table, take this department ID, then query department table to see which department he works in. If I want to see which department Atik works in, I will have to query this table and see which department ID, and then take this department ID and check what's the department name. So I have to execute two different queries, right? No, you shouldn't be executing two queries. You will instead join this table on this column. Okay, you will instead join these two tables on this column. Is that clear?
Yes.
When you write a
Yes.
query to join these two tables on the column which is common, you will have emp ID, name, department ID, and then department name. So now you don't have to query two different tables. You can just query one table and you will have the information. So when I write a query, it will display data like this: 1 Abdul, 10 IT. So you're making life easier for people by querying these two tables and giving them the query. So now they won't have to query two different tables. They can just run the query for the join, and in one shot, it will display data from employees and department tables. Is that clear to everyone?
Clear.
Yes.
Okay. Now, there are different kinds of joins. Okay, there are different kinds of joins. So the different kinds of joins is inner join, also called as equi-join, or simply called as join. We have these, and then you have left join. Then you have right join. Then you have full join, or full join, or full outer join, or full outer join. And then you have something called as a self join. Okay, let's practice all of these. So when I execute, okay, so suppose I have data like this: 3 Sam 30. And then I have 40 HR. Okay, when I do an equi-join, I will only get data when there is a join. So when I do an equi-join, this is the data I will see: 2 Atik, 20, and then sales. Is that clear? I will only get matching records. So 10 will match with this, 20 will match with this. So I will only get matching records. Guys, this is very important, okay? Every single interview, they will ask this: joins in Power Center, joins in SQL. Atik, I think they asked you this yesterday, right?
Correct. Yes, they asked me yesterday the same question.
So they asked him this question: what are the different joins in SQL? This is an equi-join because you're getting matching records. Now, this is your left table and this is your right table. Any table can be left, any table can be right. Now, let's do left join. When I do a left join, what will be my output? So my output will be everything from the left table, and matching from the right table. If there is no match, it will say null. Is this clear? Because we do not have department ID 30 here, right? Is this clear?
Yes.
I need a confirmation, otherwise I cannot proceed. This is important. Otherwise you'll not clear interviews. I need a confirmation here. Zia, is this clear? Sohail, okay. So this is left join. I will get everything from the left and only matching records from the right. And if there is no match, I will get a null. Okay, now let's do right join. Okay, what happens in right join? I will get everything from the left table. I will get in right join, I will get everything from the right table and matching records from the left table only. So this is how I will see data. Is that clear? Is this clear? This is right join. So the moment I say right, everything from right. The moment I say left join, everything from the left and matching. Equi join means I will only get matching records. If there is no join, I will not return that. Now let's look at full join. Okay. So what will happen here? I will get matching and non-matching records. So how many records will be here? Can someone answer? How many records will I see here? How many records will I see here?
You will have 4.
I will have 4. Okay. So I will have, first I will have the matching. 1, Abdul, 10, and then IT, and then 2, Atik, and then 20, and then sales. And then I will have 3, Sam, 30, and then null.
Knows.
And then I will have, I will have 40 HR, and then I will have null. I will have null. So I will have matching and non-matching records in full outer join. Clear? Is this concept clear? We are going to practice this, okay? And then we'll cover self join, okay? Can somebody share screen?
Anybody wants to go, or I can go?
Go ahead, you can share screen. Okay, let's create 2 tables. Okay, first one is emp underscore join and dpt underscore join.
Okay.
So first we'll create emp underscore join, emp ID, name, department ID.
Name.
Emp ID, emp name, and department ID. Department ID and department name.
You're supposed to put 2, right? Varchar 2. It works, I think.
Yeah, varchar 2.
Yeah. Okay.
So create those two tables. And insert data into employee table. Insert into hr.emp_join values. One comma Abdul comma 10. And then enter another value. Don't execute this, just yeah. And then 2 comma Atik comma 30. Or no, just comma 2 comma Atik comma 20. Okay. And do a commit and go to the next line and type another insert statement. Insert into the other table, department table. 10 comma IT and 30 comma sales.
Oh.
10 comma IT and 30 comma sales.
You said 30?
30 comma sales, anything.
Okay. Execute.
Yes. Okay, now let's join these two tables. Let's do an equi-join. Okay, in equi-join or inner join, it's the same thing. Okay, so type in select star from HR dot, let's keep employees table as left table. Okay, select star from HR dot emp_join. And let's call this entire table as A. Okay, go to the next line and say join. Next line, next line. You can do it in the same line, but it will be easier to understand. Join hr.emp_dept_join and then call this as B. And then go to the next line and type in on. Which column are we joining on? Department ID, right? A dot department ID equals to B dot department ID. Okay, execute this. So this is equi-join. In one shot, you're seeing employee and department information. Is that clear?
Yes.
Okay, and in employees table, we have two employees. In department table, we have two departments, but we are only showing data which has a match. Okay, now.
This one and
Yeah, the first one in both, because 20 doesn't have a match and 30 doesn't have a match in employees table. Okay, now I want to see all employees and only matching data from department. So before join, just put the word left. This will give you all employees, both the employees and the matching departments, and execute this.
I wanted to keep it. I'll mail it to others. I'll just copy. So you have both records from the employee table.
And only matching records from the
Matching.
department table.
Right.
Is that clear? Okay. Now I want all the records from the department table. So which is your right table, right? So how do you know which one is left, which one is right? The first table in your query is always your left table. Okay. And the second table, A is your first table, that right? That's your left table. And B is your right table because that's the second table. And you can join more than 2 tables. You can join 100 tables also. Okay. Now, if I want to do,
On the left side one is my driving table.
yes, the first table is always your left table. So M
Okay.
join is your first table. So that is your left table. Okay. Now I want to show everything from the department table and only matching employees. So get rid of left and then put right. And execute this. It will show all the departments and only matching data from the employees table. Is that clear? Now, if you want to see all the matching and non-matching records from both the tables, get rid of right and put full and execute this. This will show you all the matching and non-matching records. Is this clear?
Yeah.
Anybody has questions? Zia, is this clear? Inner and yes, you can get rid of full and type in inner. It's the same thing as join. Inner join and join are the same thing. You can get rid of full and type in inner. It's going to be the same thing. Before join, you can type in inner. Before join, you can type in inner. Okay, it's going to do the same thing as join.
It's just like saying left join or left outer join or right outer.
Same thing. So,
Same thing, right?
so are these 4 joins clear? Okay, let me give you an assignment now. Can you query employees table? Okay, can you display employee ID first underscore name, employee ID first underscore name, manager underscore ID, first underscore name, and manager underscore ID. Okay, execute this. Okay. I also want you to display manager underscore name.
Say it again, I'm sorry.
I also want you to display manager underscore name. I don't have a column called manager underscore name. Type in manager underscore name, it will say invalid identifier, right? It will say invalid identifier,
Yeah.
right? So get rid of manager underscore name. So I have this data, right? I have this data, right? So how can we do it? Only people from this batch. Okay, execute this. Yeah. So how will I do it?
Um, have to find out the manager's name might be in department.
Why would manager information be there in department? Departments will have department. Okay, look at the data in front of you. Forget about other tables. Why are you looking at other tables? Look at the data in front of you. Is it not giving you a hint?
Yeah, first name.
What do you mean?
Or the employee ID. I'm sorry, employee ID.
What employee ID?
The manager information, because
yes,
the employee could be the manager also, right?
Manager can be an employee, not employee can be manager.
I mean, yeah, they're around, yeah.
Okay. Okay, so let's look at the second row. What is the second row? 101, right? Employee ID is 101. The name is Nina. Who is Nina's manager?
It's Steven.
How do you know that? Because manager ID
is employee
because
ID.
A manager can be again an employee. So that manager can report to a person. That person is again an employee and that person. So this is like a hierarchy, right?
Right.
I report to Atik. Atik reports to Krishna. Krishna reports to somebody. So, but Atik is again an employee. So even though Atik is a manager, he again has an employee. Okay. So I gave a hint. So how would you do it now?
Okay.
Okay, I'll give you another hint. You have to join the same table. You have to join employees on employees. Yes, you have to say manager ID equals to employee ID.
Right.
Okay. Put a dot employee ID, a dot first underscore name, a dot manager ID. A dot first underscore name, a dot manager underscore ID. Execute this. Okay. Now go to the third line and type in join hr.employees b.
Oh, we're doing self-join.
Yeah, we are doing self-join. B on, go to the fourth line and type in on a dot manager ID equals b dot employee ID. Because a manager can be an employee, right?
Yeah.
Underscore ID. And in the select statement, type in b dot employee ID. B dot first underscore name. Underscore name as manager name. Manager underscore name, and go to the last line and type in order by a dot employee underscore ID. Execute this. Execute this. Order by. Okay, see, who is Nina's manager? It's 100, Steven, right? Okay, let's look at employee ID 104. Who is employee ID 104? It's Bruce, right? And who is Bruce's manager? Manager ID 103, right? Who is 103? It's Alexander, but you see it on the right side also, right next to Bruce's manager ID. Scroll down, next line. Scroll up, scroll up. Don't scroll here and there. Okay, go all the way to the top. Okay, look at the fourth line. Look at the fourth line. Place your cursor on 104. Okay, who is 104? It's Bruce, right? Who is Bruce's manager? Its manager ID is 103, right? Yeah. That is Alexander. How do you know it's correct? Look at the line before that.
Right.
Okay, this is how you do a self join. So on which tables can you do a self join? If a table has a relationship between two columns, like employee ID and manager ID have a relationship between them, right? Because manager ID is also an employee ID. So if a table has relationship, if one table has relationship between two columns, then you can do a self join. If they ask you in interview, have you ever done a self join? Say that, yes, I've done a self join. In one table, I had employee ID and manager ID, and I had to return the manager name. So I joined on B A dot manager ID equals to B dot employee ID. Is that clear?
Yes.
Okay, so these are all joins. Okay, these are, anybody has any questions on either left join, equi join, left join, self, right join? Okay, these are important. They'll always ask you this. Okay, now okay, so okay, so let's go back to our other query. So suppose if you have two tables, how many join statements do you need? If you're joining two tables, how many join statements do you need?
1.
So if you have three tables, you will need two joins. If you have four
joins.
tables, you will need three joins. If you have n tables, you will need n minus 1 joins. Remember that. Okay. And you can join more than two tables as well. You can join as many tables as you want. Okay, the first two tables can be left join, the second and third table can be equi join, and the third and fourth table can be full outer. It depends. You can do that. You can do all combinations of that. Okay. Now go back to your first query, the equi join. Up. Yeah, this one. Execute that. Okay, now you have a user. You have a user who wants to join employees table and department table, but they don't know how to do it. Since you're the database developer, they'll ask you to write a query and give it to them. So what do? You write a join statement. For you, it's easy. So you say, so that this person comes to you and say, I have to query employees table, pick up the department, then go to department table, and then query the department to see which department Abdul works in. This is too much for me. Can you give me one single query? So you'll say, yes, I can do that. You will write a join statement and give it to that person. Is that clear? Now, whenever this person wants to look at the data, he or she will execute this query. They will have to save this query somewhere in a notepad or an email. And every time they have a need for this, they will query this. They will query this, right? Is that clear?
Yeah.
Now, what if they lose this? What if they lose this query? They will not be able to execute this, right? So instead of you asking them to save this in a notepad or in an email or in a Word document, you can store it in the database. Okay, you can store it directly in the database. Okay, on top of the select statement, type this. On top of the select statement, type create view and then hr.emp dot underscore dept. Okay, as, and execute this. Execute this entire thing. Create and then select. Oh, okay. Get it. Just execute the select statement. I'll show you something here. I forgot to show you that. Execute the select statement. Do you see department ID is getting, the first three columns are from employee table, right? And the second two columns are from department table, right?
Yeah.
But department table is a duplicate. Department ID is a duplicate because it's coming from both tables, right? So I don't want it from both tables. So instead of star, type in type in a dot emp underscore id, comma a dot emp underscore name, comma b dot dept underscore id. You can take it from A or B, but take it from B because department information should come from department table. B dot dept underscore id, comma b dot dept underscore name, and execute the select statement. Execute just the select statement.
Oh, select.
Okay. Now execute the view as well. Complete create view, and then okay, it says view is created right on the bottom. Now
Yeah.
do select star on the view. Do select star on the view. emp underscore dept. So this you will store this query on the database itself in the view. So now when the person can simply do a select star on the view. Okay. So maximize views on the left side. See, do you see that emp underscore dept? That's the view you just created. Is that clear? Click on SQL. So this is the view you created. Create view, select star. Do you see that select a.empid a. That's the view you just created. So you're saving first of all, you're solving two issues for this user. You're joining two tables and you're storing the code in the database itself, right? Otherwise, this person would have to query two different tables. The other problem is this person would have to save that join statement somewhere in an email or in a Word document or in an email. And every time they want information, they would copy that from the email and notepad and execute it in the database. So you're solving two issues for this user. You're joining those two tables, and then you're also saving this query in the view on the database. Is that clear?
Yeah, it's easy for the non-IT guys.
Yeah, it's very easy because they would know simple select statements, but they don't know joins and they don't know how to they don't know joins and they don't know how to join those two tables, and right, they would be instead querying two different tables separately.
Yeah, in
No.
this case, also you could hide all those sensitive columns as well, right?
Yes.
Whatever you want to give them.
Yeah, I was going to come to that. Okay.
Oh,
so
sorry.
Now go back to your. So this is one use of the view. Okay, this is one use of a view. You can query, you can join multiple tables, use all of that, and then you can store it in the database. That is one big advantage of a view. And then the second advantage of a view is, for example, I don't want to employ, can you execute that select statement? Just the select statement. Okay. Or just query employees table. Just simply query employees table.
Okay.
This is the second view, or this is the second advantage of a view. Now in this, I have in this, there is a lot of sensitive information, right? There is first name, last name, salary. Okay. I have a person who only wants to see, I have a user who has a need for employee ID, first name and last name, right? You will not say, okay, query this table. right? Instead, what you can do is you can create a view and just only take in employee ID, first name and last name. Okay, so create a view again. Okay, first write your select statement. Okay, what do you want to, so this person needs employee ID, first name and last name. They don't need other information. And the other information is sensitive information. So you don't want to expose the sensitive columns to the user. So get rid of star and type in employee ID, first underscore name and last underscore name. And you can also use a where statement. So this person only needs information for department ID 60. So use a where statement also. Where department underscore ID equals 60. Okay, execute this. Department spelling. If you get invalid identifier, that means.
Yeah. I need to take ESL classes.
Okay. So you only want to display this information. Okay, you can put department ID also in the select statement. You don't want to display job ID, salary, bonus, commission percentage, manager ID. Okay, you don't want to display all of that. So that's another important advantage. That's another advantage of a view. Okay, execute this. So I have a user who needs this information, but you will not say go do select star on the employees table. You will remove the select statement access to that user from the employees table. Instead, you will create a view and say save this information in the view. So you will type in here create view hr.emp underscore dept underscore sensitive. Sorry, underscore non-sensitive. As you cannot have more than 30 characters. Remember that. Okay, now execute this.
Yeah, sorry, I just cut down.
Okay, now a view is created. Now you can say, okay, do select star on this view. You will have this information with you. Say select star on this view. Is that clear? This is the second advantage of a view. The first advantage is if a person has to join multiple tables, and if a person has to query multiple tables to get the data, you can create a view for that person, and that person can simply query the view, the date. So that person will not have to query multiple tables, and that person will not have to save that join statement. You're joining multiple tables and saving it in the database. The second advantage is for security reasons. If a person needs access to data which is to data which is in a sensitive table, in a table which has sensitive columns, you can remove the select statement access to that person. So when the person queries select star from hr.employees, it will say table or view does not exist, so you do not have permission. Instead, you can build a view for that person on top of that table and say, okay, you can query this, this will have your information. So what happens when that person queries the view? In the backend, the select statement will execute at that time. Is that clear? When somebody is executing the view in the backend, that select statement, actually the select statement is executing. Is that clear to everyone?
Yeah.
Okay, so we covered joins and we covered views. So let's cover.
So it's whether you what is it? Select from the view or from the actual table. Is there are the both are same, or which one is faster? Is there any?
Yeah, I want to cover that. Even for she said materialized view, I would have to cover something. I would have to cover something else before I can cover materialized view. Materialized view. Okay. I would have to cover something else before I would cover materialized view. And to answer both of your questions, I'm going to show that right now. Querying the table is always faster than querying a view. Okay. To answer your question briefly,
Okay.
querying, because on tables you can create indexes. Okay. And in views you cannot create indexes. Okay. Let me cover that. So
Okay. Yes.
Is this clear so far for everyone? Joins and then views. Okay. Let me share screen for a few minutes. This is a very important topic. Okay. So what is an index? Forget about databases. Can somebody tell me what is an index and where do you see an index?
We usually have it in a book.
Yes, you have it in a book. Okay. Why do you have an index on the book? For example, I have a book which doesn't have an index. Okay. And if I tell you to go to chapter 3, what will you do? You will turn each page till you reach chapter 3, right? Suppose if I ask you to go to chapter 5, you will start turning from first page. You will turn like hundreds of pages before you read chapter 5. But in a book, if you have an index, it will tell you which page it is on directly, right? So you will have chapter. This is how index looks like, right? Any book will have chapter 1, page 1. Chapter 2 could be page 15. Chapter 3 could be page 37, something like this, right? 478 and then 590, something like this, right? Suppose if you do not have this, you would have to turn each page before you reach that chapter. The same concept applies in databases. The same concept applies in databases. Suppose you have a table like this, emp ID, name, department ID, and you have 123, 761, 11, and then 456, something like this, which is 9987, something like this. And then you have Abdul, department ID 10, and then Sam, department ID 30, and then Krishna, department ID 20, and then Tom, department ID 15, and then Atik, department ID 75, something like this. Suppose you have data like this. Okay. If I want to see department ID 11, if I want to see department ID 11, so what will I, so if I want to see employee ID 11, I will write select star from table where emp ID equals to 11. You know what's going to happen? Oracle database, it's going to go and check each row where department ID, where emp ID 11, and then it will display it. Okay, it has to do. So when it checks each row, it's doing a full table scan, which is a very bad design. Full table scan. It should not be doing full table scan because it's already crossing the data, but it still will go all the way till the end and then it will display this. If I ask it to display employee ID 123, even though it's the first row, it will go here, 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 and here, and then it will display this. Suppose if I have a table which has millions of rows, okay, I have millions of rows. If I do not have an index, it will query each row in the entire table. So it's doing a full table scan unnecessarily. So you're taking up more processing power. You're blocking the table for other people, right? So when you're querying this table, other people, their query will not execute. It will be in wait status because your query is executing so long. right? Is that clear? So that's a problem if you do not have an index. Is that clear to everyone?
Yes.
Now, what happens if you create an index? Okay, what happens if you create an index? If you create an index, this table, the data will look like this itself. Okay, when you create, whether you create an index or do not create an index, the data will look like this. But internally data will be sorted. Suppose if you're creating an index on empid, internally data will be sorted in ascending or descending order. Okay, the data will be sorted like this: 4, 5, 6, 7, 6, 1, and 9, 8, 7. And over here you will have Krishna 20, and then I will have Abdul 10, and then I will have Tom 15. From outside, data will look like this itself, but internally a copy of the data is created and data is sorted in ascending order of empid because I created an index on empid. Okay, hold on. So internally data will be sorted like this. Okay, now when I say and then internally data will be sorted like this. Okay, now also what will happen is same thing will happen. So I will have page 1 over here. I will have employee IDs 0 to 100. On page 2 I will have employee IDs from 101 to 200. On page 3 I will have employee IDs from 201 to 300 and so on, just like this. Now if I say, can you give me employee ID? Okay, let me create one more. Page 4, 301 to 400. Page 5, 401 to 500. Now if I say, if I do select statement, select star from table where empid equals to 456, Oracle will directly go to this page. Just like over here, if I want to go to this chapter, I will go directly to this page, right? If I say select star from table where empid equals to 456, it will go directly to page 5. It will not query any of this. Okay, it will not query page 6, 7. It will go directly to page 5 and it will display this row. Is that clear? Is this clear to everyone?
Yes.
Okay. Now you guys can say, okay, Abdul, can we not just, I have 3 columns. Can I not create an index on this column, index on this column, and index on this column? Right? Sorry, can I not create an index on, so right now I created index only on this column. So this data got sorted in ascending order like this. You guys can say, can we not create an index on all the columns, right? Because you never know if people will be using this in the where statement or this in the where statement or this in the where statement, right? No, you cannot create indexes on every column. You know what will happen? So right now I created index on this column. Okay, right now I created index on this column. So data got sorted in ascending order and got stored like this. Suppose if I create an index on this column and this column, what will happen? Data will get sorted on this column and get stored in another page. Data will get sorted on this column and will get stored on a, so internally there will be 3 copies of the same data. One is sorted on empid, one is sorted on name, one is sorted on department ID. So that will be too much overhead for one table, right? Is that clear? So do not, if you have a table with 10 columns, do not create 10 indexes on 10 different columns. Is that clear to everyone?
Yes.
Okay. Because it will create too much overhead. So always create an index on the column which is used most of the times in the where statement. Is that clear? So always create an index on the column which is mostly used to do a search. Okay. So don't do it on the columns on which you're not doing a search. It depends on the users. If the users are doing select star from empid all the time, you have to create an index on this. Okay. Now, there are two types of indexes. Each table one index, right? No, not necessary. Okay, you can have as many indexes as you want, but be careful. Okay, you can create 2 indexes or 3. You can, so if sometimes users are using this or this or this in the wait statement, you have to create indexes on these 3. Because if you create index only on this, so select star from a table where empid equals to 4, 5, 6, only this query will run faster. If the person says select star from table where name equals to Tom, it will run very slow because it will do a full table scan and check where Tom is present. So check with the users which column they are using in the where statement. Most of the time users will be using employee ID only. They will not be using name or department ID. Okay, once again, it depends on the users, but from your end, create at least one index on the table. Okay, from your side, create index on at least one column in the table. Always pick up primary key. Okay, always pick up a primary key column. Okay, is that clear? Is that clear to everyone? Okay. And remember this, whenever you create a primary key on a column, index is automatically created. You do not, whenever you create a primary key on a column, index is automatically created on that column. Remember this. Okay, let me show you. So whenever you create a primary key column, index is automatically created on that column. And there are 2 types of indexes. Okay, there is bitmap, there is B-tree index. Okay, what is the difference between bitmap and B-tree? If a column has too many duplicates, then you create bitmap. If a column has less duplicates, you create B-tree. Can someone tell me on empid, will you create bitmap or B-tree? Yeah, you will create B-tree, right? Because primary key will not have even a single duplicate.
Abdul, I missed it. The indexes. Can you repeat it one more time, please?
From scratch?
No. The bitmap and B-tree.
It's here. So there are 2 types of indexes, bitmap and B-tree. Okay. So if I have to create an index on this column, which one will I create? Will I create bitmap or B-tree? I will create B-tree because primary key column will have very few duplicates, right?
Okay, let's duplicate many. Right.
It will never have duplicates, so you will always use B-tree. Suppose you have a gender column. You will have a gender column. Okay. So will you create bitmap or B-tree on that?
Bitmap.
You will always create bitmap. Why? Because too many duplicates. This only works in Oracle. In SQL Server, you have clustered and non-clustered index. Okay, and non-clustered. I'll cover that later. But in Oracle, you will only have bitmap and btree. Okay, on this one you will create bitmap, and this one you will create btree. Name you can use btree. Department IDs you should use bitmap because too many people work in one department, right? Right now I just created data like this, but you will have data like this usually in companies. You will have data like this. So department ID and gender will have, which has a lot of duplicates, you use bitmap. Employee ID and name you will use btree. Is that clear to everyone? And whenever you create a primary key on a column, it will automatically have a btree index on it. Okay, let's try this out. Create table emp_2_23 and emp ID number name varchar 215 and then dpt ID number. Okay, insert into emp_hr dot emp_2_23 values 1 comma Abdul comma 10 so I'll create 2 more rows, 2 comma Atik comma 20, 3 comma Sam comma 30. Okay, and I'll so table got created, 3 rows got inserted, and commit completed, right? Now let me do select star on this table. Select star from hr dot emp ID where, right? So I'm getting this data. Now, how do I know it's doing a full table scan or not? So highlight this query and you see this explain plan, execute this. Do you see full table scan? That means your database, your table is not a good table. The design of the table is not good because you do not have indexes on it. Is that clear to everyone? Is this clear? You're doing a full table scan. Okay. So let's create an index on, okay. So where do you create an index? You will create an index on employee ID column, right? Okay, so let's create an index on employee ID column. Create index. This is how you create an index. Create index, and then you have to give it some name. It should always start with IDX. You can start with ABC, XYZ, but a good programmer will use IDX. Okay, create index, and then I will say EMP underscore ID underscore 2_23, something. Create index, index name. What's the syntax for creating an index? Hold on. Create index, index name on table, and then EPID, right? It will say index created. Now let me highlight this query and get the explain plan. I am not doing a full table scan. Do you see that? It's not doing a full table scan. Is that clear to everyone? Right? Now, if I say DPT ID, if I say DPT ID equals to 10, it will again say full table scan because I'm using a non-index column, right? Is that clear? Okay, now this is clear. Okay, now let me create another table. Create table hr.dpt_2_23 department ID number department name dept_name varchar2 15 insert into values 10 comma IT and then 20 comma 20 comma sales. So data got inserted and everything. So let me get rid of this. So I'm going to join these two tables. Select star from, actually I already have it. Select star from A, join B on A dot department ID equals B dot department ID. Where A dot department ID equals 0. You guys understanding this query? So if I just execute this join, I will get two rows. I will get two rows, right? Now if I want to get the department ID and department name only for Abdul, so I will use a where statement. Okay. Now, can you tell me how many indexes do I need in this query? Wait, sorry, my mistake. A dot APID equals 10. How many indexes do I need in this query? How many indexes do I need in this query? No. I'll need an index here. I'll need an index here. I'll need an index here. So I will need 3 indexes. Okay, so when do you create indexes? On the column on which you're using where statement and join. Okay, now why do you need to create an index on the columns in which you're on the join statement? For example, I have employee table, I have emp ID, I have name, I have department ID, and then I have department table, and then I have department ID, then I have department name. If I have data like this, 10 comma Abdul comma, let me just take data from here. If I have data like this, and over here I have 40 comma IT, and then 10 comma sales, and then I have something 75 comma HR, something like this. Okay, if I have data, now if I'm joining, so what will I join on? I will join on department ID and department ID, right? So if I'm joining on department ID and department ID, 10 will go and do a full table scan, 30 will go and do a full table scan, 20 will go and do a full table scan. We don't want to do a full table scan on the join as well as where I already showed you here, right? It will go and do a full table scan, but on the joins also, on the joins also, you should, on the joins, if you're joining on this column, you should never do a full table scan. Is that clear to everyone? See what happens now. If I, let me just comment this out. Let me delete this. So if I select this and get the explain plan, it's doing a full table scan. Okay, table access is full table scan. So you should not be doing full table scan on the columns on which you're joining, otherwise it will run slow. Is that concept clear to everyone? Sohail, is that clear? Nazrul, is that clear?
It's clear, but I have a question. You know, when you showed two different type of indexes, the bitmap and the
B-tree.
B-tree. So do you mention which one to create, or is automatically by system it creates
By
it?
default, it will create B-tree. Okay, by default, because when I wrote my create index statement, I did not say anything, so it created B-tree. To create
B-tree
bitmap,
is
you
this,
have to use
so
the
it's
word
a
bitmap.
default.
Okay, is that clear?
Okay, so since the department has it's a lot of duplicates, so
You will
do
have
I
to
need?
create bitmap on it.
Okay, okay.
Okay, you shouldn't see these full table scans. Just remember that you should not be seeing these full table scans. Okay, so how do you check the explain plan? You should highlight it. You should highlight the entire and then click on this. See, I'm doing a full table scan, but for employee, I'm doing the index scan because I already created an index on this. Okay, I will have to create two more indexes on this one and this one. And this one I already created an index. Is that clear?
Yes.
Okay, because otherwise your query will run forever. Otherwise your query will run forever if you don't create indexes. Okay, so these are indexes. Index is a database object which is used to retrieve data faster. Okay, index is a database object which is used to retrieve data faster, and there are two types of indexes, bitmap and B-tree. Bitmap is created on a column which has a lot of duplicates. B-tree is created on a column which has very few duplicates, and whenever you create a primary key on a column, B-tree index is already created on that. Okay, whenever you create a primary key column, for example, let me create on department 2,23, right? I do not have a primary key column. So alter table hr dot emp underscore 2 underscore 23. No, dept underscore 2 underscore 23. Alter table name, add primary key to which department ID, right? See, I'm just creating a primary key. Automatically index will also be created. Alter table name, add primary key. Okay, this should be in parentheses.
No, your table name, it's, yeah.
Okay, table got altered. And if I go to constraints, I will see a primary key constraint here. Okay, now if I go to indexes, where is my index tab? Automatically an index got created. Okay, automatically an index got created, and you can see when you where is that? Hold on one second. Yeah, you see it got created as ascending. Automatically it creates the data in ascending order. It creates the data in ascending order. Internally, it will save it, but when you query the table, it will still show the same way how the data it was. Okay, whenever you create a primary key on a column, it automatically creates an index, B-tree index. And the other thing is when you're joining two tables, always make sure the two columns on which you're joining has indexes on them, also on the column on which you're using the where statement. Remember this for indexes. Is that concept clear? Is this concept clear? Okay, now you have tables and view, right? You can create an index on table only. You can create an index on the table only. You cannot create an index on a view. You cannot create. So now can someone tell me, is it faster to query a table or a view?
Table.
Table if it has an index. If the table doesn't have an index, that table is equivalent to a view. Okay, so if a table has an index, it will be much faster. View does not exist on the database. Okay, view does not exist on, see, table will exist on the disk. View will not exist on the disk. Okay, table will, what is a table? It will take up some space on the disk. It exists on the disk because it will take up some space on the disk. Whereas a view, it does not exist on the disk. It does not take up any space. What is a view? It is just displaying something from a table. Okay, guys, remember this. View does not take up any space on the disk. Okay, and if something is not taking up disk on the space on the disk, you cannot create an index on it, right? It's not an object which exists on the hard drive. Whereas table will exist on the hard drive. It will take up some space. Is that clear? View is nothing but you have a table, you want to just, it's like a select statement. What is a view? It's a select statement, right? If you have 10 columns, you just want to display 5 columns. So you just wrote create view as select those 5 columns from the table. So whenever you execute the view does not have anything. In turn, it will execute the select statement on the table. Is this concept clear?
Yeah.
Is this concept clear? So view, you cannot create indexes on the view because it does not exist on the disk, whereas table will exist on the disk. Okay. So to overcome this problem, we
So
have
Abdul,
something. Yeah.
okay, view does not have any indexes. So when we do a select statement on a view, so even though the table and behind the scene, basically it selects the table.
Yeah.
And even though the table has indexes, but when we do a select the view, then it just drop the index from that table?
No, it will. Okay, so suppose you do select star from a view where emp id equals to 1. Select star from the view. Select star from view. So this query will run slower. Why? Because the view does not have an index. Even though the backend will have index, but so okay, so you have a table, okay? So you have a table here. You have this table and view will be built on top of this table. So it will, even though you have an index, it will just take a subset of this data and it will display like this. So this one will not have an index.
Okay, okay. It just take an image of it,
It
but
just takes an image of it, right? It
okay,
just
okay.
displays, it just takes an image of it and displays it.
Okay, got it, got it.
To overcome this problem, this problem, we have something called as materialized views. Okay, we have something called as materialized views. I don't know if you have any materialized views here. So we have tables, views. I mean, yeah, you have materialized views here. Okay, you don't have any. Okay. So anyway, so we have, you know table, you know view. Now we have materialized views. So these materialized views exist on the disk. Okay, these materialized views exist on the disk, and you can create indexes on these. Is that clear to everyone?
Okay.
Okay, so you have view, and then you have, oh, sorry, let me use this. Okay, I'll wrap up. This is the last topic. So you have view, you have materialized view. Okay, does not exist on disk. Okay, it exists on the hard drive. Exists on hard drive. Okay, this is slow because no index can be created. This is fast because index can be created. This index can be created. This always shows the latest data. The disadvantage is does not show latest data unless refreshed. Okay, I'll cover this last line and then we'll end the class. We know that this does not exist on the disk. It just shows an image of the existing table. Slow because no index can be created. Fast because an index can be created. It shows latest data. What does this mean? Okay. Now I have an employee table. I have emp ID, name, department ID, salary, SSN, like this. I have one Abdul 10, 10,000, and then 111 hyphen 111 hyphen 1111. Okay, so I built a view on top of this. Okay, I will only display this data. Okay, so what will I write? Select emp ID, name, department ID from employee table. That's the view I create, right? When I do select star in the view, this is what it will display, right? So when I create a materialized view, right now, when I create a materialized view and materialized view, this is the data it will display. Now I add another row here to Atik 20 and 222 hyphen 222 hyphen 2222. So when I enter another row, if I do select star on the view, what will happen in the backend? It will do select star from the table, right? So now it will display, the view will display to Atik 20. But materialized will, if I do select star on the materialized view, it will only display the data which was present when the materialized view was created. Do you guys see the problem here? So if I enter one more row and if I do select star on the view, in the backend, what query will execute? Select emp ID, name, department ID from the table, right? So it will display everything. So view will always display entire data. Whereas materialized view will only display the data which was present when the view was created. If you want to see the latest data, you have to refresh this materialized view. Is that clear or not?
Yeah, clear.
Is this clear? Okay, so there are advantages and disadvantages. If you just want to see data by combining multiple columns, you're not too worried about the performance, just go with the view. Most of the times we go with the views. But if the view is too big and it's taking too long to execute, you will have to create a materialized view. Okay, the only problem is it has all advantages over views. The only problem is it will not display the latest data. It shows the snapshot. It only shows the snapshot. When suppose I had this table, I created view and materialized view when I had two records. So over here, I will have 2, Atik and 20. If I add more records to this, if I add 3, 4, 5, 6, 7, and if I do select statement, because this is not stored on the disk, right? It will at that time, it will go and do display emp ID, name and department ID. So now I will see all of this, right? I will see 3, 4, 5, 6, 7. I will see all of this. But materialized view, if you do select star on it, it will only display the two records which was present when I created this materialized view. It has static data. This has dynamic data. It shows latest data. This has static data. That means whenever the view was created at that time, what the data was there, it will only show that. So if you want to see the latest, you will have to refresh this view. Okay, there is a query for that dbms underscore refresh. You can Google about it. It will show you how the queries can be refreshed, how you can create a materialized view, and how it can be refreshed. You can have it refreshed every 6 hours or every 2 hours or every 10 minutes or every 1 second. It depends on what's the interval you want it to be refreshed. Is that clear? Usually we just refresh it once a day at like 5 p.m. or 6 p.m., something like that. Clear? The concepts of joins, indexes, views, and materialized view. Okay, let me give you the assignment. Please work on this assignment and see different types of indexes. Can you have more than one primary key? What is a foreign key? Difference between view and materialized view. Delete and truncate. Joins. I will cover triggers. Views. Why are views used? Difference between DDL and DML. Okay, so we covered half of the interview questions. Let me. What was the last? I give assignment 4, right?
No, you gave us 5.
No, I gave assignment 4 previously. We did this one today, right? We did not do assignment 5. I'm going to send you assignment 5 now.
Okay. Oh, let me see.
Assignment 5 and okay, let me send you assignment 5. Okay, let me make sure I have to remove. Am I missing anybody here? Atik, Suhail, Nazrul, Zia, Krishna, Irfan, Fareen, and Sam. Okay, let me send this and please work on this. We will have a class on Tuesday, okay? We won't have a class tomorrow. And I'll upload this recording once the class ends, okay?
Okay.
Anybody has any questions? Okay, then we'll meet on Tuesday, okay? Okay, bye everyone.
Okay.